2012, a neural network quietly trained on a stack of YouTube videos. After 3 days, it did something no one expected. It recognized a cat without any help. No labels, no rules, just patterns. That tiny spark marked a turning point in human history, the moment machines truly began to see. This is the story of deep learning, the discovery that transformed artificial intelligence from a dream into the defining technology of our age. For decades, scientists tried to build intelligence with logic and rules. If-then statements, expert systems, symbolic reasoning. It worked for chess, but not for life. The world was too messy, too ambiguous for handcrafted logic. Yet a few rebels believed the brain held the key. They dreamed of digital neurons that could learn like biological ones. Their names: Geoffrey Hinton, Yoshua Bengio, Yann LeCun. For 30 years they were ignored, their ideas dismissed as impractical, until the world finally caught up. The concept of a neural network began in 1958 with Frank Rosenblatt's perceptron. It could recognize simple patterns, lines or circles, but nothing more. In 1969, Marvin Minsky proved that without hidden layers, it was mathematically limited. Funding vanished. For 20 years, AI returned to rules and logic. But in the 1980s, three scientists changed everything: Hinton, Rumelhart, and Williams. They invented backpropagation, a way to teach multi-layer networks by sending errors backward. It worked in theory, but not in practice. Computers were too slow. Still, a seed was planted, waiting for data and power to arrive. The 2000s changed everything. Digital cameras, social media, and search engines produced an avalanche of images and text. For the first time, we had data in quantities nature never intended. At the same time, graphics cards, GPUs, designed for gaming, proved perfect for matrix math. Parallel processing turned neural training from months into days. The final ingredient arrived in 2009 with ImageNet, a dataset of 14 million labeled images. It was the playground the brain builders had been waiting for. In Toronto, two students, Alex Krzyzewski and Ilya Sutskiva, trained a deep network on ImageNet using GPUs. They called it AlexNet. It used 8 layers, millions of parameters, and a new activation called ReLU that kept neurons alive during training. When results came in, the AI world stopped. AlexNet cut error rates by half, a leap no one thought possible. Within months, tech giants hired Hinton and his students. 2012 became known as the year I woke up. Visual: AlexNet graphs, conference cheers, NVIDIA GPUs. AlexNet's architecture inspired a new breed of models, convolutional neural networks, or CNNs. Instead of analyzing raw pixels, they slide tiny filters across an image, detecting edges, textures, and patterns. Each layer builds on the previous one until the network recognizes objects with superhuman accuracy. Soon came VGG, ResNet, Inception, deeper, faster, more accurate. AI vision jumped from research labs into phones, factories, and hospitals. Machines could now see tumors, count crops, and spot galaxies. Next came sound and language. Speech was once the holy grail, too complex, too variable. Then came recurrent neural networks, RNNs, and LSTMMS. These models had memory. They could remember previous words while predicting the next. By 2016, Google Translate switched to neural translation, instantly doubling accuracy. Siri, Alexa, and Assistant became fluent. Machines were no longer silent. They could listen, respond, and converse. Deep learning runs on power. Each generation of models requires exponentially more computation. GPUs evolved into I-optimized silicon, NVIDIA tensor cores, Google TPUs, Apple neural engines. Training a model like GPT-4 costs tens of millions of dollars and consumes megawatts. This arms race drives both innovation and inequality, concentrating AI power in a few hands. Yet it also drives progress, new chips, new architectures, new possibilities. Once trained on giant datasets, models could share their knowledge. This is transfer learning, teaching one AI to build on another's experience. Suddenly you could fine-tune a vision model to spot cancer cells with just a few hundred images. Then came self-supervised learning. AI's learning from unlabeled data by predicting missing information. It's how modern language models train on trillions of words without manual labels. The AI no longer needed a teacher. it could teach itself. In 2017, a paper from Google Brain appeared with a simple title, Attention is All You Need. It introduced the transformer, a model that could understand context by paying attention to relationships between every word in a sentence. It ended the reign of RNNs and opened the door to large-scale reasoning. From that paper came BERT, T5, and GPT. By 2020, GPT-3 could write essays, poetry, and code. Deep learning had graduated from pattern recognition to knowledge generation. Generative adversarial networks, GANs, pitted two neural networks against each other in creative duels. One generated images, the other judged them. Each iteration made the generator better, until its art was indistinguishable from reality. By 2022, diffusion models like Stable Diffusion and Midjourney democratized creativity. Words became pictures, ideas became films, dreams became data. The creative barrier between human and machine vanished. But so did the certainty of truth. If AI can generate reality, how do we know what's real? For all its power, deep learning is still a black box. It learns correlation, not causation. It can hallucinate, fail at reasoning, and amplify bias. Researchers now pursue explainable AI, energy-efficient models, and hybrid systems that combine symbolic logic with neural intuition. True intelligence may require both reason and pattern, rules and creativity. Every breakthrough in AA today, from ChatGPT to autonomous vehicles, stands on the shoulders of that 2012 moment. AlexNet proved that scaling works. More data plus more compute equals more intelligence. It became the unspoken law of modern AI. And as models grow from millions to trillions of parameters, we edge closer to systems that not only learn patterns, but understand them. Deep learning is more than a technology. It's a philosophy of learning itself. Each layer reflects a layer of human understanding, from seeing edges to seeing meaning. We built machines to understand the world, but they're teaching us how understanding works. The deeper we go into AI, the more we realize the mystery is not in the machine. It's in us. If this episode opened your eyes to the power and mystery of deep learning, subscribe to FutureGen Learning and continue the journey. Next episode, Artificial General Intelligence, how close are we really? Because the story of AI didn't end with deep learning, it only began there.